Hey everybody, it is Tuesday and we're going to take notes on slope. Today you had a quiz in class over relations and functions, and I will have those grades posted this evening so you can check Pinnacle to see how well you did. Okay, let's take notes, and remember you can pause us at any time. Make sure you write down everything I write down, and make sure you watch it till the end. And again, what did I say? The 11th. And slope. Okay, well first of all, let's define slope. And I know you've heard of it. Okay, you've talked about it in other grades, and you've also maybe talked about it in science. Okay, slope. I can define slope in three ways. First, it's the steepness of a line. Okay, how steep a line is its slope. Second, rise over run. Literally, rise over run. It's a fraction. And then finally, the change in y values over the change in x values. Change in y over change in x is a shorter way of writing it. Okay, and actually if you really think about it, we've already been discussing this. We just didn't call it slope. Remember when we were talking about things being a linear function, and I gave you a chart, and we went down and we found that the rate we looked for a consistent ratio of y to x. That's basically what we were doing, is we were finding the slope. And if the slope is consistent from one point to the next, okay, then that's going to be a linear function. So really, you've already been calculating slope. You just didn't realize it. Okay, now the slope formula is M. M stands for slope. Think of a mountainside, and that's really where you think of slopes, is over in Colorado, skiing those slopes. Okay, so M is equal to the change in y values, y sub 2, or y of your second point, minus y of your first point, over the x of your second point minus x of your first point. Okay, again, it's change in y over change in x. Okay, so here I have 2 points, and I want to find out my slope. I want to calculate the slope of a line that connects these 2 points. Well, I'm just going to label, and you're going to get to the point where you don't have to label. This is point 1, point 2. And as you know, that's your x, that's your y, that's your x, and that's your y. So now I'm just taking the information and plugging into my formula. Y of my second point is 2. Minus y of my first point, which is 7. X of my second, x of my first. Now this is just an addition problem. I get negative 5 over negative 2, and a negative over a negative is a positive. So my slope is 5 over 2. And what this means is, because it's change in y over change in x, for every 5 units I move on my y-axis, I'm going to move 2 on my x-axis. Let me say that again. For every 5 units I move on my y-axis, I'm going to move 2 units on my x-axis. Okay. And there's my point. Now, you can, at this point, you can label if you want, label point 1 and point 2 and x and y. Or you can say, you know what, I don't need to do that because I can just look at it and figure it out. Okay, so that my slope says y of my second is 9 minus y of my first over x of my second minus x of my first. So when I clean this up, I get 6 over 10. And you want to simplify fractions as you do at any time. So my slope is 3/5, which means for every 3 units I move on my y, I'm going to move 5 units on my x. Okay, try this one. Now, you can stop it right now, and I want you to work this one and then resume, and you'll see it worked out. So when you plug in your information, y on my second minus y on my first, x of my second, x of my first. So that gives me 6 over negative 2, which simplifies to negative 3 over 1. Now normally you write negative 3 over 1 as just negative 3, but because I need something to represent my x and my y movement, I'm going to leave it as negative 3 over 1, which means I'm going to, for every 3 on my y, I'm going to move 1 on my x. So now, hopefully you're going to pause this and work this problem. My slope is negative 3 minus a negative 3 over 8 minus 4. Add your opposites. That's going to give me 0 over 4. So my slope is 0 over 4, which this really means I'm not moving on my y-axis, I'm just moving 4 units on my x. And we're going to talk more about this later. Right now I just want you to calculate it and leave the answer like this. And then the last one. Negative 9 minus a negative 4, 6 minus 6. This gives you a negative 5 over 0. Now going back to what you learned in 3rd grade, can you have 0 in the denominator of a fraction? Hopefully you're saying no, you can't. I can't cut a pizza in 5 pieces if I don't have a pizza to cut it in, which is basically what fractions are. Okay? I don't have anything, so therefore I can't have this. This is called an undefined slope, which we will talk about more tomorrow. And let's go up here. Let's go up here and just give it what it's called. M is equal to 0 over 4. This is a 0 slope. And again, we'll talk about this tomorrow in class. I want you to try these. So make sure you try these and you bring these to class tomorrow. And we will continue on our discussion of slope in class as well as doing an activity. Hope you guys have a great evening and make sure you check Pinnacle for your grade.